In this series, I will be focusing on modern C++, which refers to a form of C++ programming which emerged out after the introduction of a new C++ standard called C++11 in 2011. And this form of programming is still continuing to evolve. Specifically, in this recording, I will talk about move construction operation or move constructor, which is a member function of a class to get called when new object is created by copying data from another pre-existing object. I have this code to begin with. Let me explain it first, then I will go ahead and talk about copy constructor and then move constructor. Our discussion on copy constructor is useful for you to able to understand move constructor better. In this code, I have a class called student with the attribute marks pointer to point to a dynamic memory space where the marks values would have been stored, and another member to hold the number of elements in that array. And the class has the custom constructor which receives marks array and size. It does the validation, and then after that it copies the size in the num marks member, and it copies the marks into a dynamic memory space. If it not valid, if data is not valid, it sets the object into a default state. And we have a copy assignment operator. This is the code I actually explained in the previous recording while I was explaining the move assignment operator. So we have this is operator overloaded, the assignment operator overloading, and the parameter is the non-modifiable reference student type object. And if this object parameter object is not same as the current object, then it does release the memory of the current object, and it sets the current object into default state. It does the validation, and it does copying, shallow copying and deep copying, and then it returns the current object. So if you are not familiar with this kind of operation, I recommend you to go and watch one of my previous videos where I have explained copy assignment operator in detail. We have the insertion operator overloaded. This operator function actually receives OSTream object and uses that object to insert this text and the marks and spaces into the output stream in that object, and finally it returns that object that it actually received. And we have a global helper function for the class which actually allows us to display the marks data in this form. Let's say st1, right? So st1 is before talking about st1, we have a marks array, 3 marks arrays containing this marks values 1 2 3 4 values in the first array, 2 values in the second array, and I think 5 1 2 3 4 5 values in the third array. 1 2 3 4 yeah, 5 values, right? Yeah. And these are the statements to get object. I think it should be 5 here. We have 5 values. So through the invocation of the custom constructor, and this is a copy assignment operator which actually calls this function, and this is actually the statement which you can use to, if you want to insert 2 objects into the output stream, you can use it. So having discussed the code, let me switch to the terminal and try to execute this code. So we have a small issue here. Let me go and see what is the problem. Oh, I think I have a typo problem. So in the terminal I had this issue when I actually executed this compilation linking command. I had a error here. The reason I had error was I missed to have this I missed a character here, ANDL. So let me switch back to the editor and correct that. So I should have placed this ANDL. So I'm switching to the terminal one more time and try it. Compilation and linking. This is the file to be executed. We have two max values displayed, right? For max 1 object data 51.11, 67.11, 71.11, 76.11, 52.22, 67.22. So it is working, and I think the assignment should also be working. So I'm not going to be testing assignment now. The focus here first is copy constructor. Let me copy constructor is actually called when we have let me just erase this out. I didn't want this here, and let me comment this out for a moment. If I want to create a new object, let's say st4, by copying the data from an existing object, this is a syntax you have to use, st1. If I want to create a new object st4 by copying the content data from st1, remember st1 object has the max data stored in dynamic memory space. So you need to actually define a logic, write a logic to properly copy the data into a newly created object. And after that we can let me display I want to display st1 and st4, and both should have the same data. Let me go back, do the compilation and see what happens first. It did display the same data, but the problem here is that these two objects st4 st1 are actually pointing to the same dynamic memory space. So this st1 object had a dynamic memory space created through this statement, and data was stored in the dynamic memory space, and the same address is actually copied to the another the attribute of another object. That is something that is not desired. You need to do proper copying. So for that purpose you need to define a copy constructor. And the syntax for the constructor is similar to the other constructors. So first you have the name of the class itself. It doesn't have a return type, and since we are copying from the object, so the parameter should be an object of the same type, but we want to copy from unmodifiable reference type, like this. And to copy for example, if I don't want to use this copy assignment, I want to copy from the I want this copy constructor to have its own logic. In that case, what I would do is first thing I would do would be to, let's say, to set to the default state, and you can do that by setting these attributes to the default values, pointer to null ptr and number of marks equals to 0, and then you do validation not equals to null ptr. You do validation of the data belonging to this object, and then if it is valid, then you actually you copy the number of marks first. It is called shallow copying, and you actually allocate memory space, dynamic memory space, and you copy one by one, plus plus. So this is the logic that you want to place here, so that this copying happens properly. And either you create an object like this, or you create object like this, st4 equals to st1. In both cases, it is a copy constructor that is invoked, because you are actually creating a new object. In this case also you are creating new object, in this also you are creating new object. If you are creating new object, always constructor is actually invoked. Let me comment this out and comment this out. Now let us try to understand the copy construction concept. We have st1 object, like as in the code that I discussed just before. When we have st1 object created, it will have the memory space allocated for marks attribute and number of marks num marks attribute in static memory. Marks is a pointer, so it will have memory space which is sufficient to carry address, and number of marks is integer, 4 bytes, but the value stored is also 4 byte here, because st1 object has this data, and marks is carrying address of memory space in the dynamic location, an array in dynamic memory space, which is actually carrying the 4 values: 51.11, 66.11, 71.11, and 76.11. Now with this S1 object with the data that is shown over here, if we execute this statement on the left side to invoke copy constructor to create a new object called st4 by copying the data from st1 object, what happens is the object is created in static memory first. That means the address for memory space for marks and marks attribute allocated, 8 byte for address and 4 byte for number of marks, and it starts executing the logic in the copy constructor. In the beginning, if you remember the coding we did just before, first thing we did was we set the current object to default state. That means we set marks to null ptr and number of marks to 0, and then that is what happens. So address is set to null ptr and number of marks is set to 0. Next thing happened was the validation of the source object. In this case, the source object st is actually st1 object, so it sees whether the marks attribute of st1 object is not null ptr, or it is pointing to a valid address, which is actually a valid address it is pointing to, and number of marks is also positive, which is 4, which is true. So since this validation condition is going to be satisfied for this object, then the code inside that if statement does copying of the marks from st1 object to the new object. So value 4 is copying from the number of marks attribute of st1 to number of marks attribute of st4. This is called shallow copying. And then memory space is allocated for the address attribute of st4 object, which has the capacity to hold the same number of marks as in st1 object, 4 marks. And the marks values are copied one by one by this for loop. 51.11, 61.11, 71.11 and 76.11 are copied to the dynamic memory space now belonging to st4 object. Now we have two objects, and they are not sharing dynamic memory space. st4 has its own dynamic memory space, but the data is equal. Data that is stored in the dynamic memory space is equal in number and equal in value. Now st1 and st4 objects are equal, but they are not same. Now it is time to start talking MOOP construction coding. We start discussing how to code MOOP constructor using this code. This was the code I created in the previous discussion when I talked about copy constructor. Now let me go to the main function. MOOP constructor would be invoked. For example, this is a copy constructor invoked and st4 is created, and if I actually want to I don't want to have a copy of the dynamic memory st1 has. I actually want to want a new object to take ownership of that dynamic memory or resource that belong to st1 object. In that case, I actually want to invoke MOOP constructor, because I want to move the resource from one object to another object. Therefore, the syntax for invoking MOOP constructor is as follows. Again, we create a new object. Let me call this st5 and st1. If we have this syntax, it will actually invoke copy constructor. But if we have something called r value reference, we place the r value reference in the as an argument in this invocation, then that will actually look for a function which has a constructor which has r value reference as a parameter, and this function move function will actually return r value reference of st1. So it will look for a function with the constructor with the parameter which is r value reference. In this case, with only one ampersand, we have this is l value reference. So this the argument, the object, placing the object the way it is as an argument, it is actually compatible to r value reference. But if you want to explicitly pass r value reference, you can use this function. stdref is a function that will return l value reference in this case. So move will return r value reference, this ref will return l value reference, and this syntax will look for the constructor which has l value reference as a parameter. If you want this syntax to invoke the constructor with l value reference parameter, you need to define that constructor, and that constructor is called MOOP constructor. And MOOP constructor definition is kind of easier than the copy constructor. Let me call this the syntax for creating MOOP constructor is as follows. The name since it is a constructor, so the name of the function is itself the name of the class. It doesn't have return type, and you cannot have the constant parameter, because the object that comes in is going to be modified by this constructor. So we have this type, and we want to have r value reference, and the way of having r value reference is by having two ampersands. So this is a function with parameter r value reference type. Now in move constructor, we don't want to do this validation, which is not necessary. We just want to copy the you can think that you can say that you can just do some kind of shallow copying, right? So the way of doing that is nummax is equals to st dot nummax, and max equals to st dot max. So this is kind of moving the resource. Now at this point, what happens is the current object and this source object both are actually both have a max attribute, which are pointing to the same dynamic memory space, and we want to detach st object from that space. And the way of detaching st's attribute max from the dynamic memory is set this to null ptr, and you also set dot equals to 0. So these are these two lines will actually reset the source object to the default state, because if you move the resource from source object, then your assumption is that that source object will no longer need to have that resource. So you set to default state, and you are actually moving the data into the current object. This is the logic for the move constructor. And similarly, you can have a logic for move assignment. Let me just copy and create a move assignment operator logic. In this case, also we don't want to have this constant. We want to have a r value reference parameter, and you do this checking. Then after that, you do delete the max. Then once you have where you are at this point, then you don't need to do this kind of validation thing. You can just copy number of max, and you can also copy this max from. That means you're just moving the resource, right? And then you actually set again the way we did here. You set the source object into the default state. So this is the move assignment logic. And this is a move constructor logic. So and in this case, this move constructor will be invoked in this case. And if you look into this data after this, data of this st1 and st5, then you will see that data st1, the st1 doesn't have any data. It's and the st5 has the now owns the dynamic memory that previously belonged to st1, and it has a copy of the number of marks attribute. Let us check this code by compiling. We used stdref, but the library or the directive that includes that function is not included. So let us go ahead and include that. module here. So it is available. It is available through, I think, library called functional. So it should be available now because we have used this this stdref. This is actually not necessary. I can remove this, but let me check it with that library inclusion. So now it is compiled and executed. This was this is the marks belonging to st1 object and st5 object. Now in the previous case, copy construction actually actually did copy entire data, and it has its own version of the data. But in the move construction, a new object is created by actually moving the data that belonged to the previous object. Now after moving, previous object is empty, it doesn't have the data. Now this is also the equivalent syntax. You can also invoke a move constructor using this syntax. So if you don't use stdmove, it will call the again copy constructor. Now is time to learn move construction concept. Suppose I have a student object called st1, which has the attributes marks and non-marks, as I actually did in the coding practice just before. Non-marks attribute carried value 4, and the marks attribute carried an address of a dynamic memory space or dynamic array containing the 4 values 51.11, 66.11, 71.11 and 76.11. Now if I invoke this move construction operation to construct a new object called st5 by moving the resources from st1 object, first thing that happens is st5 object is created with the attribute marks and number of marks. And now when the marks of st1 object is actually assigned to marks of the new object, current object, then at this point what happens is this st5 attribute marks and st1 attribute marks actually carry the same address of this dynamic memory. That means both point to the same memory space, and then we actually detach the st1 object's marks attribute from that dynamic memory space, and we can do that by actually setting this marks attribute of st1 object to null ptr. Then after that what happens is this dynamic memory actually no longer belongs to st1, and it belongs to st5 object. That means st5 object is now taking ownership of that dynamic memory. That means dynamic memory is being moved from st1 object to st5 object. Now we also copy the number of marks data 4 from st1 object to st5 object. This is a shallow copying. And finally we set the st1 object's attribute to the default values. The purpose of this operation, I mean setting num marks to 0 and marks to null ptr, is to actually detach the marks attribute from the dynamic memory space, which is necessary if you want to actually transfer the ownership of the resource or data from one object to another object. Now we will talk about code localization. Code localization is a concept that we can use to minimize the amount of code that is present in the class logic, in the logic of the class. If you look into the let me just put this copy constructor and copy assignment together. Now we have a move constructor and assignment together. So if you look into this two functions, this lines and these lines of code are same, and it is in the good code. If you want to make your code efficient, then you need to minimize the repetition of the code. So the way of minimizing this code repetition is localization. You put this code in one place, and then so that there is no repetition of this code. And there are two ways of localizing the code. One way is you can just copy all these things, and you can have a function, maybe private function set, put this logic, this code is here, and since we are using this st object, you need to pass this object in the parameter. So this will actually set this object data into the current object. Now if we have this set function, and then we will be calling this function from both the move constructor and move assignment operator. That will actually make sure that these lines of the code is not repeated. So from here, instead of having this course, these lines, you can call that set function and pass st to it. So, and also here you can call the set function and pass st. Comment this out. This is the way of localizing the code. This is a member function, and you call the member, you put the code that is the repeated code in this function and call that function from both places. That is one way of doing it. Another way of doing it is direct call of this assignment operator. So here we place the code in the assignment operator, and at this point the current object is already created, so you can invoke this copy assignment operator from here, equals to st. If you do like this, it will go ahead and call that copy assignment operator, but you don't want to call copy assignment from the move constructor. So you want to call move assignment from move constructor, so you have to place this. You need to actually pass the r value reference as an argument to the invocation of this function. So this is going to be move assignment now. Similarly, you can also do the same code localization in the case of copy constructor. This is all I plan to discuss in this topic. Thank you for watching the video.